Section 2.3, we're going to start graphing equations of lines. Most of the lines that we will graph will be in slope-intercept form, so all I have to do is look at the equation, pick out the y-intercept, plot that, then use our slope and count the rise over run to plot a couple more points. But we'll also look at a case where they might be in what's called standard form, and we will use the x and y intercepts to plot graphs. Sometimes that's a little bit easier, so we'll look at a couple examples of each of those cases. So again, most lines that we will deal with are in slope-intercept form. We have y equals mx plus b, where m is the slope and b is the y-intercept. One thing I want to look at quick is, why is this the y-intercept? You've probably just been told that it is the y-intercept, but why is that the y-intercept? So first of all, just a little bit of scratch work. Let's think about a graph. If we're on the y-axis, the x-coordinate of any point on the y-axis, if we're on the y-axis, the x-coordinate is always 0. So what we would be doing to find a y-intercept is plugging in 0 for x. So if we plug in 0 for x, this term just disappears, right? We would have m times 0, and that's 0, and so y is whatever number we have here. So if we plug in 0 for x, we end up with this, so that's why this value is always the y-intercept, right? So looking at this first example that we have here, if we plug in 0 for x, we would have y equals -2. So 0, -2 is a point on that graph, and that is kind of just happens to be the y-intercept. So we would have our y-intercept at -2, and then we count our rise over run with our slope. So our slope is 3/4. So our rise is 3, our run is 4. So I'll draw some other points here. And again, this should be familiar to you. You did this quite a bit in Algebra 1. You would have done this again in Algebra 2, or sorry, in Geometry. This is Algebra 2, and we are doing it again in Algebra 2. So there's our lines. Rise over run is 3, so up 1, 2, 3, over 1, 2, 3, 4. There's a point. We could go up and right again, but I'll run out of room. So we could also go down and to the left. So down 1, 2, 3, and a run of 1, 2, 3, 4. So there's another point on our graph, and then we draw our line through those points. Simple as that. In our other example, we have a y-intercept of -3, so down 1, 2, 3. All right, there's a y-intercept, and then our slope is a -2, so that's a -2 over 1. So we're going to be going down and to the right. So again, let me just draw a few more hash marks on our graph. I recommend drawing at least 3 points. The further away you get them, the more accurate your line's going to be. So down 3, there's our y-intercept, and then -2 over 1 for our rise over run. So down 2 over 1, and then again we could go the opposite way. Up 2, left 1, up 2, left 1, and those are all good points on there. And then my super secret trick to graphing is, if you miss any points, just take and draw those points a little bit bigger until you hit your line. Not a true secret to graphing, a little bit of a sarcastic tip there, but hey, it works most of the time. So sometimes we might not be given slope-intercept form. It might not be in that y equals mx plus b. Sometimes we can use x and y intercepts to plot things a little bit easier. So first of all, we already talked about what a y-intercept is. That's when we're on the y-axis, right? And any point on the y-axis is going to be 0 and then some y. Well, then what's an x-intercept? X-intercepts are probably actually, in a lot of applications, more important than y-intercepts down the road, especially when you get like into calculus. X-intercepts are important. But anyway, what's an x-intercept? Well, that's when we're on the x-axis. Right? And if we're on the x-axis, then our y-coordinate is 0. So it's some x value, and then the y-coordinate is 0. So we can find x and y-intercepts by plugging in 0 for x if we want to find a y-intercept, or 0 for y if we want to find an x-intercept. So In these couple examples, we're going to find the x and y-intercepts. But on this one, we'll also look at and see how that could be helpful or make things pretty simple to graph. So first of all, on this one, let's do the y-intercept first. So if we want to find the y-intercept here, then we plug in 0 for x. All right, so we'd have 3 over 4 times 0 minus 2. This whole term goes away, and so we just have y equals negative 2. Is this the one that was on the last page? I think it is. So there's our y-intercept. What about our x-intercept? Well, then the y-coordinate is 0. So we plug in 0 for y. We have 0 equals 3/4 x minus 2. And then this is essentially just solving those single variable equations that we've done in the past. So I would say add 2 to both sides. So 2 equals 3/4 x, and then divide by 3/4 or multiply by 4/3, right? To cancel out on that side, and so what do we have? 8/3. So our x-intercept would be at a positive 8/3. So let's look at this next one, where it's not in slope-intercept form. We have 2x plus 3y equals a negative 12. So again, to find the y-intercept, we would plug in 0 for x and see what we get for y. Well, if we plug in 0 for x, that first term goes away, and so we have 3y equals negative 12. Well, then we just have to divide both sides by 3, and we get y equals negative 4, right? Let's put this back. Then if we want to find the x-intercept, we know that the x-intercept is some x value and then 0 for y. So let's put in 0 for y, and 3 times 0 would be 0. So that term just disappears. We can cover it up. And then we just need to divide both sides by 2. Divide both sides by 2, and we get a negative 6 for our x-intercept. So our x-intercept is at negative 6, 0. Well, this gets us 2 points that are on this line. So we could actually very easily graph our line from this form. We have an x-intercept at negative 6. We know our y-intercept is at negative 4. And all it takes is 2 points to be able to graph a line. So we could draw our line through those 2 points. So if you're given an equation that looks like this and told to graph it, an easier way to do that might be using x and y-intercepts. Just plug in 0 for one of them. So plug in 0 for x to find the y-intercept, plug in 0 for y to get the x-intercept, and then there's 2 points right there that you can plot. If we were to rearrange this and put it into slope-intercept form, we would get the exact same line, but I think that this can sometimes be a little bit less work, so keep that in mind as you graph some of the lines.